Yes, I can hear you.
Okay, all right. So are you ready?
Yes, I'm fine.
Okay, all right. So let me start with an introduction first. Uh, okay, can you see my PowerPoint?
Yes, I do.
Okay, good. Okay, hello everyone. Welcome everyone to this Quantum Science and Computing free online forum. I'm Dr. Carlo Ng, the co-chair of the Quantum Computing Research Center. So this forum is here is our organized committee. Okay, this me and this is Dr. Katie Huang and Alex Sun. Okay, the aim of this forum is to provide a platform for learning the basics and the latest development of quantum science and computing. So I hope that this forum is able to inspire and motivate you to pursue your curiosity and passion for quantum science and computing. So here is the website for this the research center. HTTPS quantum.asia.edu.tw. So once you join this link, then you can click on this hyperlink. This will forward you to this web page, and then you can sign up, okay, for any event. And sorry. Now remember, you just need to sign up one time. No need to do it again. We will just keep all the record in our database. So if there is any new event coming on, then we will email the event details to you. And this is the Google form where you can sign up. Now, we also like you to take a more active participation in this online forum. So we call for a presentation. So you just click on this link, and then read the instruction. After that, you can download the form over here. And please fill in the form and then email it back to this Gmail address for approval. Then we will arrange, once it is approved, then we will arrange the talk according to your time available. Now, subject to the speaker approval, we will send you the lecture notes and the link of the video recording, usually within 5 days after the presentation. Now, this is subject to the speaker approval, right? Now, today we are very pleased to have Dr. K.S. John Huang to give a talk with the title Optical Photonic Computers, Basics, Advanced, and Trends. Dr. Huang was a prior research staff, a member of IBM. He's also the principal engineer of Rockwell, senior manager, technical leader of Cisco. He also worked as the CEO and the chief technical officer of EdgeWave Chicony Software. He also has been an engineer consultant of Tesla Solar City. He received his PhD in electrical engineering system University of California, and then received his master in electrical engineering at California Institute. He's a graduate from National Taiwan University. He has published more than 40 journals and more than 20 patents and invention. You also have published a book on digital optical cellular image theory, architecture, and implementation implementation, right? So for that, he is a very experienced and expert on the optical systems. So, sorry. So I will remind Dr. Huang know when there are 10 minutes left and 5 minutes left, so the speaker can finish on time. So Professor Huang, would you mind we have a question during your presentation, or you would mind to put it at the end of your talk?
I don't mind. If anyone have a critical question, please raise your voice. Yeah, I'm great to hear whatever comment or corrections, and I expect many of you can pick my mistake and
Okay.
my out of date. Yeah,
Okay.
immediately. Yeah.
Okay. So then let me stop sharing.
Okay, so I begin to share mine.
So yes, go ahead and see.
Okay. You see mine?
Yes, good. Okay.
Right. Full screen. Anyone see the title page?
Yes.
Yeah. Great.
Yes.
I'm so happy to accept Professor Wu's invitations. This field is moving so fast, advancing so fast, and I expect and wish some of you can correct my mistake. And more important and more interesting is now and just right now, we are all connected with light to learn together and to laugh together on how we can compute with light. Light is so easily seen, but so difficult to grasp. And yet the most mysterious fundamental essence of known science, including physics, right? And all other science and arts and faith. So light deserve our words, all of our attention right now. So let's do our best to have fun together. And I never knew that a very dumb boys or very primitive toy fun work with light can be published as a book and then translated by distinguished Chinese professors to publish as Chinese version. And then still very kindly mentioned this year, that's after more than 30 years since my graduate fund. So the infinity that I happen to know is my own stupidity and lies unlimited, amazing grace, wisdom, and power. The Dosip Day remind me the mysterious dark room aesthetic experience in the dark room as well as in life. My life, I believe all of you can recall those dark room experience. Boy, boy, with no phone, where shall I go? Long, long, dark night, long, long, dark room, to whom I belong. The more I understand my darkness, then I will see the light's infinity wisdom. Amazing content entanglement keep happening in my life. Since my first day was born, and then even the name, it is with light. And it was changed by an elder when my father go to register in government. And I was so stupid, and then have been stoned to near death, or to bump into car, or have many near death experience. And I never knew I'd be able to study with Richard Feynman. And then even more amazing is I find out Richard Feynman's thesis is published by the same publisher. He has much more contribution than me. However, my one is published earlier than his. And that is the day I was asked to interpret some of the scripture binding on who is in front will become the date. That means what we can do is whatever we can do our best. And life is so amazing grace. And then besides my work in high-tech career, the most of time in my vacations is in the dark room, in prison dark room, walk through hundreds of the ion bars. So amazing. And it is happened. The starting day, the complete date is starting as the 7 by 7 days. So this also related to exactly how we will do, because Feynman's thesis and my thesis basically all derived from the way of light. That is the least action principle. Feynman's thesis is using the classical mechanics, the list of action principle applied and derived to the new path integral form for quantum mechanics, and then enable many useful things for quantum field. So same thing, my work is to apply that to the optical computing architecture and algorithm. So I will introduce my methodology in my whole life, and then apply to how to study this field according to my experience and my limited view. So please correct me and then allow my mistake. I know there are definitely tons of things to improve. So basically, I treat it as the two periods. The first period for Kishu, it is starting from the 1980s period time. That is the survey also mentioned my work as the first one that they mentioned from that time to now, and now is also booming. And the second piece is after the intrinsic quantum behavior, very tiny scale, especially for the individual photons behavior and intrinsic behavior. And that is after around 2000 to now. And which way will be the best, I think, is also very depending on the problems to be solved. So I will summarize some of the trend. So the methodology, the least action principle, fundamentally come from the energy conservation, and we should not waste the energy with love, just like how light come to sell me and come to like a Samaritan, good Samaritan, like my daughter. If I was drowning and my daughter can how to come to help me, always with the best energy efficient and least time to sell me, not with the least difficult period or the superficial short pass. Basically, is the overall best synergize depending on the situations. And the light basically suddenly travel all over the world, is constantly spin, constantly connected with the optical field or electromagnetic field in all over the universe. So based on this, how we can create the best feature. That's the fundamental methodology I used. So what is light? Basically, it defines what's the energy packet, E equals to h mu, and then E equal to mc squared, also defined what's the limit of information speed, as well as the conservation of energy, okay? And when we travel with light, basically t equal to 0. So there is no normal light, normal time or space. Basically, it transcends all the time and space. And more effective probably is that it create the space and time with us. So that quanta is to right now try to use the behavior of quanta. It has no charge and no race mass, and it defined the basics fundamentals, many fundamental things for this universe, just like c equal to constant. So it implies c is the speed of light, implies light is more fundamental than mass. And it defines what's the energy, okay? And its spin is the most fundamental elementary particle, okay? The other popular one is the electron. So it is used in our current classical, we so-called classical machine, but in fact, it is also based on quantum phenomena. There is the minor difference because light do not have mass, and it has the spin equal to 1, so it can superimpose without a limit. But for the electron, it will collide to each other. Okay, that's the major difference, and it has mass. So the light behavior will be throughout for these presentations and will serve as the guidance for whatever my thinking. Okay, so correct me if there is any mistake. It seems like it can smell and take all the parts and interfere with itself. And basically, it is fully connected with the whole universal, the optical quantum field, the electrical magnetic field. And the known physics fundamentally deal the same one and only one reality, but just like at different time, different space, and human means understanding is limited to our knowledge. To me, it's light to guide us to know light better and better, deeper and deeper. And today we are very close to the theory or anything. It has a couple candidates, but we don't know exactly, or we cannot fully approve it. However, we can see that this action principle can be used to derive all the known physics. So the least action principle to me is the essence to guide all of us, including all the creatures in this universe, how to work together. And regarding to the quantizations, we are in a more quantum world. However, according to the history or our knowledge is starting from the particle work. Basically, consider it as the no superposition is from geometrical optics or classical mechanics. Those are without the quantization. And then the first quantization is based on the discretion using the wave function, including the interference. And then the second quantization, that is the quantum field theory and corresponding to the quantum optics. So we are approaching to the underlying physical reality, and all of them are guided by the dispersion principle, just at different limit and different scale. And quantum mechanics, we have three known formulations. So how we choose? Again, it is a broader sense of the dispersion principle. It's depending on the problem we face. So which one we can solve with directly use with less energy is the action principle preferred one. So it all depending on the problem. Overall, Feynman's using this action principle, the sum of history, to formulate it, and then it can derive the Feynman diagram, and so easier to use in the field theory and many body physics. And today, our quantum computer or our quantum algorithm usually using the matrix type of the operator relationship. So similar things is applied to how our action, how we work on a project, even just like the DOSI project or whatever I have worked in the technology or in the mission project, or based on this kind of thinking, is fundamentally keep asking myself how light is working, how light is guiding me, how light is interact with me, how light is measure me, how light is computing me, and then given the existing constraint, the time, space, and resource, and what's the intuition will be the base, the value in line with the light, then you will reduce to what we can differentiate and what's the strategy, and then put into action. A fundamental is the teamwork excellence. It will be the base, the synergy. We can see even the teamwork of ants follow this action principle. However, the human being often find each other, like how many wars we have seen today in the world. So basically, we need to keep modify ourselves and thinking back and repostulate. Basically, this is the same as the science and technology, the development methodology. Okay, so keep asking and seek and knock and put into actions with our best heart, best mind, best soul, best strength. Okay. So how we classify the computers or OQCs? Today, people often call a quantum computer as the cubic one, but in reality, all the things in this world probably can be called a certain degree of the fundamentally, because we are in a mechanical world, so we are more quantum computers, but just like by different representations and encoding. For example, even intrinsic quantum computing, it can have ternary coding, just like what we have in the existing classical computer. They can be multi-level encoding as well. And then analog computing is also infinity, very variable. Okay. So, but we can see the most popular one is the bit encoding, but it also can be considered is the error correction code from the qubit. Okay. So there are interlinked relationships among all of them, and for OKQ, the optical computer or optical or photonic quantum computer, because they are inherently have some unique features. It's different from electron. As we just shortly mentioned. So we will see how they corresponding to each other and then how they basically work together. It all depending on exactly what's the problem we try to solve. So fundamentally, this type of computer is more toward a specialized computer or special purpose or special purpose while general purpose capable. Okay, and technology we can see from our elementary schools calculator of numbers from the mechanical things to electronics or to hybrid or optical computer. They have many hybrid and many combinations. And although today we seldom hear about analog computer, but actually analog electronic computer and optical computer exist many ways if we watch carefully. For example, just like the with telescope, how we see the faraway place, or like the optical lithography machine, how we define our semiconductor progress. Okay, that's the basic classification. So fundamentally, most people talk about why optical computers usually trace to Feynman's early days study the papers in the 1992, but the first talk is in the conference of 1981. He particularly mentioned nature isn't critical. So if we want to make a simulation of nature, or we like to understand like the deep calculations of to better simulate the nature, then we have better make it also quantum mechanical. So it is a wonderful problem because it is not so easy, and we can see right now already how many years, more than 30 years passed, and we haven't had the truly commercial machine, like just like our PC, although they are commercial machine in the outside, but basically it's not making so much profit at this moment. And fundamentally, because the nature isn't classical, so basically it's like no classical phenomena. So because our eyes is too rough, so we say the classical phenomenon is only the approximations to the quantum phenomenon, and quantum phenomenon is much more close to the reality. So today we know the quantum technology and optics basically has the quantum phenomenon manifested almost everywhere. Later I will explain more. So all optical computers also has the similar power as the quantum computers claimed, most of them. Okay, so we will see and discuss more what exactly the physics behind that and how we leverage it. And for this development, we need to very careful of practicabilities. The things why we think the quantum computer or the optical computers have high potential because the problem size increase. We see the classical electronic computers, they were hitting the exponential difficulty due to the exponential growth of time requirement. So there will be a certain cross point sometimes in the future. And right now the gauge is about around a weeks if the problem size require around weeks of calculations. Yeah. And this is in the 1985 when in our class of potentiality and limitations. And at that time, because the basic consideration is the limit of the classical computing machines. So it's assuming it's the binary gate-based type. So the physical size is limited by the size of the atom, and the energy is limited by the required computation time. Algorithm and architecture can play a significant role there. And information propagation is limited by the speed of light. Although today we talk about in quantum entanglement, but it is the global, it basically is the property of the whole system. Holistic view is not the information from one place to the other place, but just they act simultaneously. It's the global property. So here are some of the reasons why we consider quantum computers. Basically, people think physical process can be efficiently simulated on a quantum computers because they are all fundamentally quantum. But this is not fundamentally agreed or the worldwide agreed by all experts. Maybe have some exception, some difficulty, some problem we cannot solve easily or fully simulated. I mean, just like we have got their incomplete theory, so there maybe have some limitation, but overall it should be be able to find, I mean, some difficult problem, probably with the guide of light, human mean, maybe to discover something together with light. And quantum computers are interesting physical systems is in their own right, and nature is more quantum. And if we are in the world of quantum computers, then today will be changed. Things will be changed. We will need to abandon most of algorithms that we use today, just like software update, email, online banking, and the entire realm of public key cryptography and digital signatures. Those rely on the ISA key, okay, or the ECC. Those will be not enough. That will be definitely will be break. And why consider optical or photonic QC? Fundamental is photons are ubiquitous and cost efficient. And photons are not collide to destroy each other and not restrict to a particular location and can be easily routed. And information encoded in photons requires no quantum transducing for interchip communications, and it can easily operate at the room temperature, and we can easily reserve. And more detail we will discuss later. So also the other is the environment. We see the current electronics face the limitation, just like the Moore's law is hitting the ceiling, and the growth of the data because of the internet network, computer sensor data, and ever-increasing computing power for new innovation requirement, especially recently, AI like ChatGPT or the multi-universe those AI situations causing to the exponential growth of the data processing requirement. Okay, now we go to the basic one. We can see interference is the fundamental one, and it including especially superposition. That is itself intrinsic is the superposition state, and then the entanglement situations for entanglement. In classical interference is the macroscopic expression of all of the quantum interference. Okay. And the first characteristic feature we can see all QC will exist is high bandwidth. Okay, in the frequency it would be 100,000 times larger than electronics, and then the spatial period it could be higher. Although today's VLSI is extremely high, however, typically because the heat dissipation only about 3% of the electronic transistor can be turned on in a single clock cycle. And then the dissipation rates, we can see this Fourier optics, the correlations is near no energy loss, and then can perform such the high computation power just with the speed of light. And the transmission loss is much lower. However, in a very short distance within the chip, so far still using the electronics, but eventually it is moved toward from the long distance gradually into the between chip and perhaps also inside the chip. And optical beam, it do not cross each other, either the free space being traveling over the waveguide crossing. And then it can be still programmed at a speed for the whole structures like within milliseconds. However, in the VLSI processors, their configurations, they are basically fixed in the geography. If we like to program it, they configure it, it is very slow. Also the fan-in and fan-out capability, okay? And then the quantum nature of light is accessible because it is the higher than the room temperature, the thermal energy in the room. So it is basically is be able to accessible at the room temperature. And then the individual photon can also be easily seen, not just view those superposition and entanglement effect. Those interference can be easily set up. Just those interferometer in almost all the undergraduate lab. Okay, and the last feature, again, those are this action principle or the least energy dissipation. So those can be leveraged. Inherently, it is the optimization nature. So it can be used to construct optimization machines, just like the EC machines. Okay, because we use QED as the basic physics theory, and we can see those basic process in the quantum electrodynamics. Fundamentally, it's just the particle moving and coupling, and that is corresponding to a computer. Is to use the moving is used to connecting, communicating, or networking, and then computing is used those coupling or interference or interaction. So we can see they are fundamentally can apply using this action principle to both situations. So this is the architecture I would consider we can use this as the fundamental framework. So basically, it's the connecting, one is connecting unit and the other is the computing unit. So computing unit mostly is based on circuit or gate based, and connecting unit can be introduced for the data cluster and major based. And it both technology, actually connecting technology like the hologram can, when it hologram or back optics or fiber or waveguide, if they introduce some of the depth measurement, it also can be simulated as some of the capability, or they, when we do the measurement, actually it get usually a complete logic word, including negative is the inversion capability, like the CNOT in the qubit, or like the no gate in the binary, right? In the binary logic set. So gate is easier to ensure, I mean, the inversions be able to do the computing, but the advantage will come from how to combine like this kind of circuit based, is circuit or gate based, and with the cluster and measurement based, and they can work out together depending on exactly what we try to solve, or what resource maturity we have. So hologram is so powerful, and fundamentally, as far as I know, most current theory is considered the universe fundamental is a hologram projection. The boundary of this universe actually encoding all the information what we need. And this is the examples how can it use for the interconnection or memory or interferometers. And nonlinear optics or linear optical array can also use for the optical gate and processor element array. Or we can introduce electronics, electro-optics, or optoelectronic in there, but just do the conversion. Because electronics is easier to do the switch and generation and regeneration. Okay, so this is what I propose for those interested in to enter this area. You probably start from this kind of framework and then get into the detail. And depending on the problem and application, very fundamental is this kind of OQC success design will be very depending on the right definition of what is the right optimization function, what is the right least action principle for particular limits. Okay. And make the best use of whatever we discuss, those 10 great features for optics and the interference, either in the space or in the quantum or the Maxwell, those interference, those are fundamentally can be leveraged to simulate or to encoding a large volume of information for processing and maximize those pros effects and minimize those cone effects. And so far, the linear approach, measurement induced nonlinearity is more popular in this OQC development, what I see, because their technology barrier is lower. And this is what I did in the DOSIP architecture before. That is the one plane is the processing element, and the other plane is the connection elements. But actually, their technology will be interchanged too. And this is how I did before with my team. Basically, the difficulty is the coherence. Same thing for the current days quantum computer, because the coherence in the optical beam, it requires to control the environment, especially difficulty is in the hologram fabrications. It is multi-phases, and each one requires multi exposures. So the time, the energy control, the environment control is extremely difficult. So that's why I have so many mysterious darkroom experience, which help me grow up aware, which is extremely critical experience for me. The coherence is so critical in the success for all optical systems. And the complexity and the advantage compared to others. And that is same thing. And we can see the optical computing paper and become bumping up again, especially recently year. And it also the analog type of the AI approach or neuromorphic or recursive neural net, those are quite a few startups just do this as the special purpose extract or in a spatial environment. And the other approach is the highly integrated photonic IC, especially from the communication side. And how far we can see actually those special purpose one exist almost every field. For example, last year I got a prostate cancer, and I think some of you have been praying for me, and I have been domestic here by the light, so it's have been dropped from 214 and below 01. So that is the amazing grace from light too. Okay, then do the advanced portions after 2000s. That is try to leverage the intrinsic quantum behavior. Basically, photon exactly Poincare sphere is and the Brock sphere, they are exactly matching. Okay. The fundamental difficulty for this day is still the fidelity poor device. The trouble is there is not enough high fidelity of quantum bonding or the number of qubit yet. And very poor compatibility among all the layers and vendors, and it is just still in a very early stage. But every day you require the ecosystems development. And for optical qubit, it can encode it in many ways, or it can encode it as the Q3 bit or Q dupe. They are similar like what we have in the computer science series, can have all different kind of encoding, but because bit is relative simplest, so we right now most cases are focused on bit, qubit, okay, and polarization and spatial encoding are the most popular one. Simply just using the beam splitter, and so the single qubit gate can use the phase shift and beam splitter. Those are exactly the same as the back optics. Exactly the same as my system. What I done for creating the whole one. Those multi phases and multi interconnections. Those are parallel interconnection whole one. The same phenomenon, similar phenomenon, and similar setup. And if require 2 qubit gates, then it become very hard. So right, there are a couple different ways, and the linear optical way, that is so far is the most popular one as far as I know. Please correct me if I'm wrong. So this is the called KLM scheme. That is their first introduced. Yeah, so it is measurement induced nonlinearity, basically using the linear optical components. Although individually may not work, but held together, those non-deterministic gate can become working as just like this case as the C0 gate. So the basic element become extremely simple, just as the classical. I mean, the old optical computers doing in the back optics or in the waveguide, phase shift and beam splitter. Those are the fundamental element. This is the implementation of C0. Okay. So we see two fundamental approach. The circuit or gate-based photons are difficult to interact with. So the progress is more difficult, and cluster and measurement-based, those become easier. They basically using the post selection and introduce the measurement dependent outcome, so they are equivalent to the circuit gate, but they become, because the nonlinearity requirement is not so strong as the switching as the gate-based. So they are fundamentally, they can interchange each other, and this is their comparison. And we see the measurement right now in the optical arena is quantum, and Zalendo has the most visible one, and quantum try to introduce 1 million qubit by 2024. And this is the roadmap for those measurements. And today we are actually still in a very early stage, still in the noisy intermediate scale of quantum computing that is trying to allow noise. And hopefully after 5 years, we can about enter to the fault-tolerant capability. And these are the existing ecosystem. And photonic computing is considered one of the good candidate. Those 4 greens, the promising one, and these 2 are considered as the leader. So in this measurement, this is 2023. Their major is the 92 is the base. That is Canadian optical company. Okay. However, today the largest cubic announcement is come from a small quantum computing company called Quantum Computing Inc. Yesterday, these 3 days, I just received a notice and check. They say they use the Raspberry type of computer, that is the information Raspberry, just like the breakfast, and it is derived from the recurrent neural net. It implement 11,000 qubits with a very tiny device, similar, just a little bit bigger than the mouse. However, when I check into their store, they look like not so promising. The trouble, I think, is the whole ecosystem, or how to fully use, and then how fidelity, what's the quality, and how's the compatibility, and how to use. There are so many things need to work together. Not just one small company can easy to attract the whole industry. So, but this is today's largest qubit announcement in the world. Okay, and for the side content, we see they have the new algorithm. Okay, they basically they claim they have the new active Boolean compilations, so it can reducing the time and cost of running quantum algorithm by 50 times. However, they didn't announce their fully working the new qubit machines. Although their roadmap is 1 million in 2025, but we didn't see the real machine yet. Most are in the software or the algorithm or architecture level, or probably some prototype they don't like to announce. And Xanadu also have similar things. Looks like when I look into their website, they have the most programmability capability and teachings. So looks like why ICV rank this company is the most mature optical quantum computer up to now. Okay, this is their qubit. And then China implemented 255 photonics quantum computer. Okay, but the trouble for this is basically they are just can be considered as the one optical experiment set up without any programmability. So they keep increase their number of qubits and claim the highest quantum supremacy. But we don't know how practical this machine yet, because we didn't see the programmability capability can fit into exactly real world situations. However, it's a good experiment and good demonstrate of how powerful optical quantum computer can be. Okay, and then the cloud service right now, the trying to in optical arena to provide a photonic software, to provide the quantum software to program the OQC. And this is the overall market presence, perhaps. Those are highly guessed. Okay. So medical looks like is highly regarded. And in ICV, they think finance, security, and pharmaceutical. So compare these two, we can see most likely, yeah, medical, pharmaceutical, and yeah, they are quite similar. Okay, and this is the market prediction, but usually your prediction sometimes could be marketing force and may not be so realistic. Just like today, the largest cubic announcement, the company we can see has been have been in a public company for more than 10 years, but looks like it's not so promising. And the stock value need to face the true reality in the market situations. Yeah, it's the same thing. Okay. Again, it looks like pharmaceutical is considered as the largest in security and finance. And we can see in this year, the ecosystem construction, US still evaluates the overall the best in terms of balance. However, in terms of government support, China is the highest. You can see China allow like the Jiuzhang, like each one, just keep each year, be able to just pump in more cubic. And without the true commercial value, we can see their optical demonstration, government support is extremely high. Okay, so this is the final trend. What I say, compared to last year, we think we will move into 100 cubic. We do see IBM also surpass the 100 cubics, and also we have the QCI with the 11,000 cubic. But looks like the market is not so popular yet. That means there's something wrong. So that means the second one, fidelity and error correction, that is extremely important. And low temperature chip-based measurement and control system, and software and algorithm also required to support it to be truly useful. Okay, and the rates are similar. People can just see. And okay, so we probably will toward more and more focus on exactly what can be useful. So just like we can see those successful spatial purpose one. So number one thing need to focus is the application need to be very problem oriented. So we can define the right action principle to do the work, do the overall selection of the hardware architecture, software architecture, and firmware as well. Okay. Okay, so that's about it. So I stop here. So I hope everyone can grab the essence. Basically, is using this action principle, and try to correct me. Any question? Hello? Hello? Hello?
Hello, hello.
Yes, we can hear you.
Okay, all right. Okay, so it's time for open question for the audience. Anyone, can you open your microphone, or you can type your question in the chat box? Yes.
Yes.
Questions from the audience? Can you hear me? Hello. Okay. So let me pose a few questions first.
Okay.
My first question is, because the photon do not interact, so how would you implement the entanglement between the two photon qubit?
So you two photon qubits. So here you can see. Let me show some of this example here.
Yeah, because there's no coupling between photon, at least in the quantum electrodynamic in the QED in the first order. I think maybe in the first order correction, there's no photon-photon interaction. So, but in quantum computing, you need qubit entanglement. So how would you deal with this situation? Because there's no photon interaction.
So if you can see, they use some of the non-deterministic gates. So they do the teleportation, right? They move information and without measure it, and then after this non-determined gate, then they connect together, and then they have then the overall, when they huddle together, their overall behavior, they can serve as those entangled, like the different type of required entangled gate. Somehow this one, so that's why most company or most paper, as far as the progress, has more progress, are all based on this post measurement selections. It's come from the measurement induced non-linearity, non-the nonlinear optics. Nonlinear optics, those crystal, some of the crystal also have this high nonlinear capability, but somehow the switching time, for example, what I use when I my graduate time, those switching time is so slow, and those effect but in the fiber right now, they are coupling. They also use the coupling effect. I'm not an expert in this kind of material of the gate creations. Okay, those I'm more architecture or the overall large system design. So those individual gates, how they construct, you can look into like this 2 qubit gates. Those have the 6. They have 6 examples. They can use either with the most popular post measurement induced effect, the linear optics one, or use the strong nonlinearity, or use the geographic phase in Hilbert space, or amplified with nonlinearity, or the quantum signal, or interaction-free measurement. Those are the existing long 6 types of this gate effect.
Oh, so those are these So those are the six approach.
Six approach for the 2 cubic. Yeah, have this kind of 2 cubic effect. 2 cubic gates. Yeah, but detail. I'm not an expert on those material.
I will follow this.
Sorry about that. I think you are much better than me on this.
I see. Okay, I will follow the reference you cite over here.
Okay, that's in the page 50. Okay.
Yes, page 50. Okay, all right. Do I need to unmute the audience so you can speak over the microphone? Is it? Yeah. Is any question from the audience? Do I need to do something to unmute or?
Any more question?
Then, if not, then I'd like to follow up more questions.
Okay.
You also mentioned about the horography in optics, but the horography, as far as I know, it you have two light beamed, where they have the interference effect due to the phase information.
Right. So that is equivalent to. So that actually is the superposition and the entanglement in magnifications in the free space, the dark optics. So fundamental. That's why many people think holography, the principle of holography, is the ultimate reality or the ultimate theory. Right? We are basically it is from bit. Is to carry, the universe is carrying and giving us the information and also measure us, recording us by the holography.
Okay, but so how would you implement the holography in the photonic machine?
And right now, interferometer serves the holography capability that is recording the interference patterns. So holography, if you have the dynamic spatial line modulated in the space, then become each, right? For example, each phases recording the interference. And in the integrated optics, those coupling, those interferometer is the same effect. But just one is in the bulk optics, in the whole like the photographic plate. Okay, but for example, in the one that I use is the dichromatic gelatin holography. So basically, it's the glass, then coating with the some of the sensitive gelatin type of the material, so it can recode in the interference pattern. And this stays in some of dynamic spatial line modulator, and it can do the similar things, and all in the fiber, right? In the optical waveguide, then those fiber can cooperate and do the same effect. So you can see all of those OQC companies, or like the Chuzhang, okay, they all have these interferometers. Those interferometers is to do the similar things as the whole one, but they are in the quantum based, in the photonic based, instead of the whole beam based. Or actually, my hologram is also multiple beams, but just small a plate in each piece corresponding to a multiple exposure elements of the hologram. So there are many holograms in the plate. And that each hologram can be served as the function like the interferometer in each of the fiber optics network. So that's why you can see right now the largest qubit announcement is from the Quantum Computing Inc. They announced 11,000 because right now the fiber optics and photonics integrated optics improvement advance so quickly. So they are expected to be able to demonstrate 10 to the 9th like the pixel-based type of the communications. And that's also why we can see that quantum prepare to announce more than 1 million of qubit next year. So it do have the strong hope for optics to compete with the semiconductor-based or trap ion-based. So that's why the top 3 are these three types. Yeah. So optics, photon-based always is high hope, especially it is operated in the room temperature.
Yeah.
Yeah. So the cost is much cheaper. You can see those quantum computer Inc. only 40 employees, but they are announced the largest qubit-based computer in the world. I don't suppose 11,000 is extreme. It's much higher than IBM. IBM is 400 something, right? Today reach 400 something. Suppose the highest maturity company is IBM's because they work such a long time and such right? Have put in so much money. But then the optical company, they all prepare to announce much higher volume.
Oh.
You can see, so looks like this is some interesting phenomena.
Okay.
Okay. So any help to you guys? So sorry, I'm no longer in the optics lab for quite a long time. It's so happy to go back to my own experience.
I have another question is, in one of your slides, you talk about encoding, and then you talk about the phase and encoding, right? Also, maybe amplitude.
Amplitude and intensity. So far, the detector only become the intensity, become the quantum collapse. Okay, so the detector is only detect the intensity. However, during the computing, we see actually they are compute with all logs. For example, hologram, right? They actually is recording to the phase information as well. So they do the
Dr. Huang, you hit your mute. Your microphone is muted.
Sorry. Yeah. What
Okay.
I say is that in detector only detect the intensity, but during the computations, they actually can compute phase information as well as amplitude, because underneath the optics propagate, it including the amplitude and the phase information, just like the optical propagation. Okay, free space optical propagation is a Fourier transform, and if we put the lens is to move a large distance, large systems without any optical element to a focal length as the Fourier transform. Okay, and so when we do the measurement, it becomes the quantum collapse. It becomes what we can see is the intensity. So the detections in the no matter which system, the in the end is detect the intensity. Okay, but the encoding is try to be able, right? For example, right now we try to leverage the intrinsic, those complex number behavior. But complex number we cannot directly detect. I saw the quantum computer, the difficulty is similar like the optical, the large free space optical systems like the wake telescope. So those difficulty or the optical lithography, those difficulty, 光刻机 those difficulty are the same. It's the coherence, how to make sure all the calculations, those are coherent without the interrupt from the environment. Because any noise, it becomes the quantum collapse. So for the big system, it's also destroy the large systems superpositions or the entanglement effect that we try to leverage in the computing.
Yeah, there's also the problem of photon loss and thermal noise in optical quantum computer.
Right. It's basically very similar in the classical superposition and classical entanglement. Those effects is similar in the quantum effect. Because they're inside, they all have the exponential ikx, those kind of angular, the spin or right in the spin manifest in the right that system, that's polarizations, right? That's the fundamentally is something is not be able to directly detect, and to interrupt it, it become cause the all the noisy, and so that I think that's why you can see those optical machines are so expensive and also so difficult to progress. Extremely expensive and extremely noise sensitive, extremely difficult to maintain the coherence. And same thing is like for I think for our daily life practice, when we watch the sky, we can see twinkle twinkle little star, right? How I wonder what you are, or like pass through the light pass through the dips or to the angle, it become have all kind of diffraction. And then if you try to measure it by the different angle, it become changed so quickly. I mean, so you can see that the holographic patterns, the interference pattern, we cannot basically it can consider as like the quantum entanglement. It is like information is encoded and then become a secret information. It only can be retrieved by the original reference bin. Only original reference bin can retrieve the information. So that is the same as the quantum entanglement. That is to try to entangle the information into a surface plane. So this is the information series become exactly corresponding to the energy. Energy change is information. Okay. And then the entropy is the hidden information. And we are so tend to destroy our discipline. And so that's why entropy become kept in large. And then this action principle is keep guiding us to have the best discipline. So that's why I like this action principle so much. and hasn't.
It's very useful.
Huh?
It's very useful in deriving, say, the Newton's law, or deriving the Schrodinger equation, also the Einstein-Hilbert action equation.
Yeah, also Maxwell equation too.
Yes, yeah, Maxwell equation.
So
yes.
that means as far as we can see, even the string theory also can be derived from there.
Oh, really? Okay.
Yeah.
I'm not for string
That
theory.
is because it just basically is it become make it from the quantum path become the string path.
Okay.
So so
Okay.
so
Yes.
there's something very unique, very strange, and a
Yeah.
kind of amazing grace that light is so visible. We can so easy to try to learn, but so difficult to grasp. Even the depth or the meaning is so difficult, and even to construct a very high coherent time machine is so difficult.
Yeah.
So right now, all the claim is kind of dangerous of the overhype. For example, things I do in the graduate, those kind of prototype. So many years have been passed, and so many government or the company have been so many staff and so many projects, and we can see only some extremely important things, or like in the weapon or synthetic aperture radar, or those kind of things, or in the optical lithography machine and 光刻机 or the web telescope, those extremely expensive one.
Yeah.
Can still exist, but for a commercial, that is very difficult to achieve, like the PC or smartphone, because this PC smartphone has been so well manufactured. I mean, the technology for manufacturing is so mature, but for the optical systems, it's not quite there. And those are takes very long time to develop, I think, because my experience, those stuff.
Okay.
Long line experience. I know that kind of coherence, reservation, the maintaining such high coherence is not difficult. It's not an easy job. Sorry. Do we have the optical lab at Asia University?
No, I don't think we have optical, but we do have the confocal microscope. Confocal microscope.
So those for medical usage.
For biological sample imaging. Yeah, but I don't think we have an optical instrument. Yes. Okay, I think I would also like, we still have 2 more minutes, and see if there's any question from the audience. Yes, do I need? Yes.
Yeah, can I ask a question? Okay. First of all, thank you, Dr. Huang. Okay, your speech is very, very wonderful.
Thank you so much. You are so kind.
Yeah. And we are heard about more the architecture and some related with the hardware explanation about the quantum. Okay, but can you provide us some software view? Because as we know, the Google already emphasized 3 times or more the quantum supremacy. Yeah. Right. So and they also provided some very, very powerful calculation and using the application. Yes. And so we want to know, is some kind, maybe, as you mentioned, maybe the whole universe holographic is more look like the 大圆致敬 or 大圆镜智 in Chinese. I know you must know what I'm talking about. And so maybe in some software computing, some software power will be drive another thinking of the how to use the quantum computers. Yes, and maybe could you talk about more about this? Yeah.
Yeah, sure. Yeah, this is very interesting and fundamental. This universe is more information based rather than material based. To my understanding, basically, it's trying to convey the this mother universe, the loving message to us. Okay, and it is very depending on our attitude. The humility is the key to have very strong correlation or entanglement with the modern machine. It is in the way of light. So light is extremely mysterious, and it carry the information. It defined how we pass the information message. So hologram serve as the big discovery, okay, in the human history in last century. However, the same difficulty as the overall OQC is the overall control, but it is very depending on those granularity, the coherent state. So I spend majority time is to play with the holography, and this holography serves as the foundations of how we can most effective encoding information. So, like Feynman is similar than Newton or Einstein has made a mistake. At that time, when we discuss, we think the information is 3D boring type. Okay, but then later, like we know the one invented VLSI, he think it should be the surface, like our neuron is surface 2D. And then later I read a couple books like the Bradford the Bradford War and a couple others regarding to the universe holographic principle. It become looks like more and more promising. It's like the modern machine or God or light, it decoded all the informations in the boundary. So every moment every moment actually create a new time and space, and it is encoded in the surface, space-time surface. And with light to pass through, it becomes generated all the information coming out. So this kind of this is similar like the quantum we try to do in the every photon or quantum. Okay, it's through this mysterious, they can simultaneously to search through all the possible paths. The same effect is in recoding this quantum entanglement effect, that is the quantum interference. So it is recoded it, and until basically later it will be retrieved, or it can be retrieved through the right reference bin. So information encoding, the density, the capability is proportional to the area, not the volume. That is its universe. As far as I reach through those cosmology, the most common agree is in the surface. That is the same as carbon meat. The VLSI, that is the Zhang Zhongmo always show that book, that it introduction to the VLSI. So that is the surface encoding. This kind of interference content, that is the content interference encoding. It is the fundamental encoding skill of this universe. So just like the information is put into put into a book, for example, is separated into different page, and then scramble, and we need to combine together. It is kind of it become the quantum cryptography, similar like the quantum cryptography, because the interference plane, we look into those interference plate. Almost nobody can see what is that. But once it retrieve, it become a 3D, could be very beautiful young lady, beautiful kid, or beautiful dog. But when we look into the interference pattern, nobody know. So that is the universe, the coding, the highest example is we can see in the hologram. So this is kind of more like the associate memory. It is stored to multiple. Basically, information is not just one particular locality that our today's memory, one at a time. So it has the global property. I don't. So that means the programmability for this kind of quantum computer should be very different from the today's classical computer, because it should be more association based, more relational, instead of hard rigid locality. That's what I think. And so I would think there are tons of opportunity for this OQC developments, and especially right now, all the country devoted so much money into just doing this kind of crazy prototype. But once it reaches certain stability, then it is required software, firmware, be able to make it realistic, and it would be very powerful. But we don't know it. Actually, I personally feel it is very depending on the overall human hearts together, the humility level. The more humble and more loving kindness, then the universe will give us the gift or grace beyond what we can imagine. The trouble is that these days looks like we all in the people is more empire. I mean, more to fight each other, and then you can see all the faces, all the face in the world, all such high regarded, and then desire the fundamental elements. The essential face is on light, on love. However, the action become hatred. You can see human beings' heart is so easy to corrupt. So because of that, then we always have the dependency. We cannot fully achieve to the level of the information maximum, encoding maximum, or the light, like computing with light, the full capability. Because bottom line, if it is the contradict to the characteristic of light, then light won't give us that. Just like the double split did they experiment like to measure our heart? They know whether we like to do a measurement or not, and then change their way. When we do the measurement, and it will become more particle light, right? And then, or even they can change the history. If we think what is light in the, just using the spatial relativity, T equal 0, right? If we have the V equal to C, there is basically no time and no space. So light is be able to transcend all history. So light detect all of our heart. So light will make the ultimate decision. So what we say we are measure light, reality is more toward is the mutual interaction, and more correctly because light is surrounding all of us, right? And then kissing us, and then giving us life, and then he is measure us rather than we measure light. Just like Earth and the sun are surrounding each other, right? How we often say original is the Earth base center or the solar base center. Reality, they are intertwined together. They are just like quantum entangled together. They are kind of mutual relationship. Same thing. Right now, our progress, everything actually is the mutual relationship with light. For this area, computing with light. So we need to measure how we need to fundamentally. So whatever the colleague or the students that are able to work, the most important is the humility, the right attitude to work with light, just like how humble to work with us. But what we can do a switch on and off, that is because we come to know light to a certain degree. So light grants us the capability to control to a certain degree. But to the ultimate, like this kind of using the intrinsic capability of light, it is very, very 99, I think 99.99% is very depending on our human beings, together the heart maturity. Because overall is light to connect the whole universe and connect all of us and measure all. So right now in quantum computing, the very dangerous things or something very challenging is that we try to control the behavior, the intrinsic behavior of quantum. But reality, light even know before, just like the disaction principle or light, how can he know right now he come to the different index material, right? Or whether we will put the delay measurement where we will change by to put a detector and light knows it. That's the most mysterious things, and we need to be very respected to light. That is fundamentally, I think we human beings, we need to come together. Is like technology and science need to go back to the morality together with moral mind to have the respect to this most mysterious fundamental essence of all faith, all known faith, or physics, the light, what is light that he expects from us. We must have a better coherence. And software would be the fundamental. So the essence is those interference pattern that is light measure the other light. And we are the hidden light at this moment.
Okay, sorry for the interruption. I think we are a bit over time. Yeah. So,
Yes, thank you.
Yes. So I think it's time we can close our presentation. So thanks again very much for your nice presentation, and take you so much time to for the Q&A question. I think is very interesting and illuminating.
Thank you so much.
Yeah.
Correct me if I'm wrong. I definitely a lot of things need to improve. Yeah, so interesting to learn together with everyone. Thank you.
Thank you. I will maybe have a private communication with you after the talk.
Welcome anytime. Yeah.
Okay. So welcome everybody, and I think it's time we can close this presentation. We're going to upload the lecture notes as well as the video within 5 days. Okay. So all right. Bye everyone.
Thank you everyone.
Bye.
Good night.
Bye.